from an archive tag. While with electronic banding, we don't need the volunteers to stay on the field for a long time holding scopes or binoculars to try to record any banded birds that come into their site. But for big birds, there are a lot of powerful choices. For those tiny birds, you just need to deploy enough scanner or receiver at that site. And the birds can be spotted automatically and identified accurately. Well, E-band is actually a very simple and good idea, but also encounters a lot of challenge. For example, can we make tags for birds as small as 30 grams and still able to record many data? Can we make them to have all the unique advantages of the traditional bands, cheap, easy to do, and still make the volunteering community feel enjoyed and benefit and contribute to this career? Just as you can see, this black-faced spoonbill is wearing a powerful tracker from us with about 1,000 GPS per day and many other data, but it still wears several colorful plastic bands. Here, I'd like to describe what we planned for the electronic banding system and how we're going to tackle all the challenges it's facing for small birds, especially. The whole system is very simple. It consists of two parts, the E-band and the gateway. The E-band, with a strict limitation on weight and size, will not be able to do remote communication by itself, but it is capable of data transmission of 100 to 1.5 kilometers, depending on the environment and the gateway type you choose. And the gateway will upload all the data to the cloud. And then the researcher can have the data in their accounts. What kind of E-bands we have now? Basically, there are 4 types. The first type has all the functions except the cellular or satellite transmission. With solar and battery, it gives you hundreds of GPS per day for most shorebirds, and you get useful environmental data, continuous ODBA, and XYZ raw acceleration data for behavior research. While the second type, due to the weight limitation, should be a geolocator and a beacon, while the other data types are the same. The third and the fourth type will locate as a beacon. A beacon means it doesn't generate locations by itself, but derives its location from connecting to other things with GPS. Beacon locating is actually much more accurate than a geolocator, but it needs a gateway. So the availability of the gateway just determines the value of the beacon locators. Just like the example I listed yesterday, a gateway will be like the charging pile for electronic cars, like the cell tower for mobile phones. Now let's take a look at the gateways we can use. Firstly, the gateway will be the other of our GPS trackers that are working on this Earth. They can interact with each other. If a GPS tracker detects that a beacon is near it, it will record and report to the server during its own communication session. Then the researcher will be able to know when, where a certain bird individual is recited. If the tracker has enough ability, it will also help the beacon to upload other data stored in its memory. The second type is the ordinary smartphones we use every day. As long as it has a Bluetooth function and a debut app, it will be a gateway. Think of it, it's just a huge network of over 3 billion mobile gateways. Whenever you want, you just hold your phone and scan in the air, and you can contribute valuable data for bird researcher and conservation. The third type is still a mobile phone with a special device we developed called Quest. You can enhance your smartphone's signal range to up to 800 meters. This is designed for more advanced users, such as the skillful volunteers. They have valuable skills for the field work. When they are collecting data, they can also contribute other valuable information. The fourth and the fifth type, they are actually of the same type, just with different level of functions. They are both powered by solar and battery, and automatically search for the events and help them upload the data. This here is a general comparison of tag and hub. Tag can be hanged on a pole or a tree in everyone's backyard, and a hub has the most powerful functions and can be installed anywhere on land. And the hub has an external antenna for better radio frequency performance that is suitable to be used in sites with large flocks of birds. And it is capable of fast scanning and large volume data collecting and storing and uploading. I'm gonna turn back to illustrate a little bit. You can see the gateways network is actually designed with different levels to involve as much people as possible, both professionals and ordinary citizens. Everyone can enjoy and contribute to the great career of bird study and conservation. With greater ability, you can still contribute valuable information just with better tools. As ordinary people, you can contribute with a simple gesture or a small cost. Isn't this an even better and bigger community? Next, I'm gonna introduce the core technology behind this system. It's called Interlink. Interlink is short for intelligent linking. It is a near-field communication method based on Bluetooth, and it is super low power consuming, and it enables interaction between different debut series trackers and ordinary smartphones to connect to the debut series trackers via Bluetooth. We choose, we already have, not we, just in this industry, UHF and VHF are already used for near field communication. Why we don't insist to that and choose to develop Interlink? Because not only because it can utilize the existing huge network of over 3 billion gateways on Earth, but also with phones we can connect every people. So the idea is that the Interlink is just a bridge between people and wildlife and nature. Now I'm gonna go through something you can do with Interlink. Firstly, you can use the app to scan and count the trackers or birds. You can just turn on the debut app, click the Interlink icon in the middle, and you will see all the devices nearby. You can clearly know how many are there and what is the power level right now. Are they in off or on status? Are they near you, or are they comparatively far away? Since there's a signal strength display, the nearer, the stronger the signals will be. If you want to find a certain bird or device, you just choose from that list. Then the app will start to make the ringing sound. You listen to the sound and try different directions. If the sound is getting louder and louder, then it means you are getting closer to the target. Otherwise, you adjust the direction. This function has proved to be very helpful in the fields when the researchers want to search for certain individuals, or sometimes when they lost a device in the field, they can use this function to retrieve them. There are also many other options you can be done remotely in different ways, directly from a phone, or a phone and a Quest, or an independent gateway. When you tap a device, here, you will see the menu of all operations. Let's take a look at each of them and how it is useful to you. Firstly, turning on. You just turn it on anytime, anywhere with a phone. When you turn it on, you can decide the basic settings you want to use, and you can just easily customize settings by yourself. You don't have to specify them before you receive them. You can change your ideas anytime. And turning off, we offer two modes, hibernate and really turn it off. The only difference is that a hibernate device can still respond with Bluetooth signals, while turning off is not. So sometimes you attach the device on birds, but you want them to start working later to save some power. You just hibernate a device and activate them again just before you want to release the birds. And this also proved to be very helpful for some researchers, because especially when they have to deal with a lot of devices at one time during the field work. It's easier for them to forget turning them on, or have some of the device running out of power before releasing the bird. So this function is going to help you sort it out clearly and make sure everything goes right. Next thing is the delivery setting. After the devices are released with the birds, you can still change the settings as long as the device can be connected by phone or our tag or hub. We also use the device to collect the most data within its ability. If a bird is sometimes the researcher might want to use different settings in different season, weather, or locations, or depends on the tag, the device on status. So be able to change settings anytime would be good. So if the bird is not far from you, you just use the phone to scan and change the setting. If the bird is far away, you can just set settings to the hub, and the hub will help you change the setting whenever it can spot the device. Next one, data collecting. This is the key function. When you are in the field, you can use your phone or a phone with a Quest to scan a device and download data from them. Or the other gateways along their road will download the data automatically for you. Data uploading. This is usually done automatically and immediately when the bird downloading, when the data downloading is finished. However, in some situation, you might have you might not have network connection in the field. So in this case, the data will be stored in the phone, and when you come back, you just manually upload them. Also, please note that the other operations, such as turning on and off and change settings, will require you to log in as the owner of the device. You need to log into the account to do these operations, but this is to avoid improper operations. But data downloading and uploading will be open to anyone. This is to encourage everyone to participate and contribute, and the data safely goes to the cloud and presented in the right account. You might also see which user at what time and what place contribute the data, just like the band sighting reports. So it should be a good way to keep the community enjoying, benefit, and contribute. The next one, data labeling. When you tap the option, the phone camera will start recording, and the XYZ acceleration data will be shown on the screen in real time. And at the same time, you choose the behavior tags when you recognize behavior such as resting or foraging or flying. Then the video, the acceleration data, and the marks you made will be combined under this consistent timestamps, and you can use it for further analysis or later verification because you have a video. This is a new function and many users might not have tried it before. So I use another picture to illustrate the whole idea. A bird, when a bird is within your sight, well, I think it's, well, I used a goal here, but I think it's especially good for shorebirds because they will spend a lot of time on walking on the beaches and easier for bird watchers to see them. When a bird is within your sight, you use the phone to connect to it, connect to the device on it, and start shooting the videos and connecting raw acceleration data from it and choose labels for it. These three things are done in the same time, in the real time, and the marked data with video proof will be stored as valuable first-hand data for behavior analysis, and everyone is able to contribute with their knowledge and observation or just a small gesture of scanning. And we intend to make the behavior analysis a new dimension for bird researchers with solid first-hand data, just like the GPS trackers. So with more data, the research and conservation of the bird will be more comprehensive and interesting. Okay, and here I would like to invite my colleague Guozheng, the designer of the whole system, to illustrate more on this topic, as well as the shared network and community is going to build. Thanks.
Okay, thank you, and please stay sharing your screen. And okay. Thank you for Lin's introduction. I will just briefly summarize what Lin's talked, because there's a lot of concept. Oh, sorry. There's a lot of concept and there's a lot of new ideas, and I will just summarize a little bit about what Lin's just talked. So the first thing is about the tracker and the e-bending. So how we identify the concept of those two different things. So when we talk about like a tracker, we're talking about the device, the electronic device with like a long distance communication. The long distance communication means it have the satellite communication, or it have a cellular communication. In this case, basically, so it's more like a tracker. You deploy the device on the bird. Then it's similar like the philosophy of once you deploy it and you're done for your work, and you can go back home, and basically all the data will just transmit to the cellular tower, then back to the server, or direct transmit through the satellites, then to the server. So basically, all the other things you need to do is just log in your account with your PC or with your smartphone, and you got all the data. It's more like a subscription, so like a Netflix or other, service provider. So the data will be automatically uploaded every day if the device is within the network coverage. And when we talk about e-bending, so we're talking about something you can't get the data directly. So basically, that is because, you know, when we talk about the tracker, the most two part, which is very energy consuming, is the module of GPS, give you the precise positioning and the fix. And the other thing is the long distance communication, like cellular module or the satellite module. So when we're talking about the Shorebird, usually it's a small bird. So we need to minimize the size and the weight of the device. So we need to cut some of the function. And the function we cut first is the long-term communication. And we replace that with near field communication. And when we talk about near field communication, it can be UHF, VHF. That is very traditional way we usually use. And you know, like the network of motors also use VHF or UHF frequency to do the communication. But what we use and promote for that e-banding concept is Bluetooth. And you know, we're pretty familiar with Bluetooth. It's generally used in our cell phone and laptop. And at the beginning, when Bluetooth 2.0, the communication will be very limited. It's just like 1 meter. And if you move your Bluetooth mouse to 1 meter away, you know, you will lose the connection. So that is the very traditional Bluetooth. But with the technology development, now we have Bluetooth 5.0. The good part of that is, first thing, it can communicate the distance, communication distance, although it's near field, but it's fairly acceptable for the ornithology research, because it can up to 1.5 kilometer to 2 kilometer. So that is basically enough distance. Sometimes even if you can't see the birds, and you can collect the data and you can find where the birds are. And the other things is very low energy consumption. So when we do the raw data connection, for example, if you use your cell phone to connect to the e-banding device. So basically you can have very smooth and very intensive data transmitting for the real-time 3-axis accelerometer data. So that is very important for us to do the behavior research on modeling. So that is what we call the E-band. That is based on the new Bluetooth technology. And when we call the E-banding, so that is basically, we adopt the concept of banding. So think about that, like for hundreds of years in this research field, a lot of people just contribute a lot for their time. And what they do is, you know, they report the band bird. So, but at that time, because we don't have electronic technology, so basically you first you need to spend your time and stay in where the birds are and looking for the birds and find the band ring. Then you just maybe, you know, publish your recording on a newspaper or something, and then maybe email. But still, it's not that efficient. So at this moment, you know, you know, now we can just use e-banding concept. Basically, it's the same. So the only difference is now we have a very powerful tool, which is a smartphone. So basically, if we have a smartphone and we download the app, so which is also mentioned by Lin, which is called the Debut. It's you know, the app what we develop. So then you will empower your smartphone to have the capability to connect to the E-band device. Then no matter where the where the E-bands are. So you are searching for that. And if the communication distance is within, for example, one kilometer or 500 meter, then you can get all the E-band function, what Lin just mentioned. So that will be saving a lot of time. The first thing, you don't need to buy any extra things. For example, if we use VHF tag, so you need to bring a receiver with you. And usually if you want to get a better performance, you need to have a very large antenna. And you need to moving the antenna to point to the tag and get some information. So for this case, you need to do all the things in purpose. You need to travel with all the device. But at this moment, everyone have your cell phone. You can't leave your cell phone. Basically, if you are in certain place, you will have your cell phone there. So, and you can, for example, if you have a cup of coffee in Starbucks, so then you can just get yourself smartphone and turn on the mobile app. Then just searching. If there's any birds next to you, you got all the data, and you can just directly connect with the device and got all the raw data of accelerometer. And for the accelerometer part, because we don't recording that all the time, so it's only generated and activated by the app. So because it's too much data. But once you meet the birds, then you can just contribute to the whole research society for the bird raw data for behavior analysis. So we use this kind of concept to saving a lot of time, or we sharing some of your extra time. Because when you drink the coffee, actually you're just relaxing yourself, but you can just contribute some of your relaxing time, and it's also for fun. And you just recording something. If there's any E-banded bird next to you, then the whole society will benefit out of that. So that's why we call this concept also as banding, because the basic philosophy and the basic fundamental idea will be the same as banding. And the other things I want to clarify is, we have a different node. The first thing is a device, the E-banding device or tracker is the terminal. The terminal is like where we generated the data, do the data acquisition. And then Lin mentioned another thing is called gateway. So the gateway is more like a data collector and the data transmitter. So usually when we talk about the tracker, the gateway and the banding device, those are combined together. So when we talk about the tracker, first the tracker can collect the data, then transmit the data to the cloud. But when we want to make the device as small as we can, we decoupling those two things. For the device which deployed on the birds, which we call the E-banding, is basically just have the capability for data collection. For example, it have a GPS to give you the location information. It have the MEMS, all the sensors to give you some environmental information like temperature, pressure, like humidity or any kind of things. And the third thing, it will give you some behavior data, like ODBA or like raw data of the accelerometer. But it don't have the capability to transmit all the things to the server. So you need a gateway which use the near field Bluetooth to collect all the data from the E-banding device to that gateway. then the gateway have the capability, because the gateway have a large power battery. So it have a sufficient, when you hold a gateway, you don't really need to care about how weight they are, because it's not on the birds. We care about the weight on the birds, but not the weight on ourselves. Although, you know, we also care about ourselves, but it's not that much, right? So we carry a gateway. The gateway can be the very simple things. It's your smartphone. So you can use your smartphone to collect all the data from the e-banding device. And the second thing, it can be a smartphone with what we call the Quest. The Quest is more like a large antenna, but it's actually super tiny, small. It's just like a flash drive. So you hold the Quest, that is more like a communication extender. So, and you still use your cell phone. And it can empower the communication distance and extend the communication distance of your cell phone. And you will have a better capability to collect the data and connect with e-banding device. This is the second kind of gateway. And the third kind of gateway, what we call this hub. The hub is more like a base station. So the difference of hub and a smartphone or smartphone plus Quest is like, so for the smartphone, you need to have a people there to operate the smartphone. But for example, if we have a lot of birds on the land, on the island, so you can't just, you know, always living there and use your cell phone to collect the data. There's two things. The first thing, you don't have enough power to power your cell phone. You know, it needs to recharge all the time, and maybe every day nowadays. And the second thing is you need to, you know, have some food, and you need to sleep. You need to get a lot of things. You can't all keep like working 24 hours and 7 days a week. So then we use the hub, that base station, to replace your work. So basically you put a hub there, and the hub will just scan all the time. And if there's any birds with an e-banding device come near the hub, then it will just directly pull all the data from the device and upload that to the server. So we use this combination. The first thing, to minimize the weight of the device on the birds. And the second thing is still have the same function as the tracker. So that is basically the whole idea of the system design. And also, you know, we want, because nowadays, you know, the smartphone, the mobile communication really changed a lot of kind of things in our life. You know, we got to, you know, make our life much easier for the consumer end. And what we want to do is adopt all the, you know, like technology, and try to make the scientific research and all the researchers' life much easier and more efficient. Because think about that, we spend a lot of time, which is very valuable for the researcher, for the data collecting. And there's a lot of data because of the weight of the device, or because of all other things. We can't get a lot of type of data, we can't get that. And you know, with the new technology and the, you know, we can do more, and with more dimension of the raw data, the fundamental data. And I think it will be leverage the wisdom of the whole research society to do much more, you know, in very outstanding research work.